Powers of Polynomials, product of binomial conjugates. There are 6 topics we want to discuss in this lesson. First, vocabulary. Second, know how to raise a product to a power. Third, know the power of a monomial. Fourth, simplify the square of a binomial. Fifth, evaluate quadratic functions and write them in standard form. And lastly, find the product of 2 binomial conjugates. Please take time to pause the video so you can write down the 2 vocabulary words. Okay, binomial conjugates. Binomial conjugates are the sum and difference of 2 terms. So for example, x plus 5, x minus 5. I have the sum and the difference of x and 5. Another example, y squared minus z squared and y squared plus z squared. I have the sum and difference of y squared and z squared. Binomial conjugates. The product of 2 binomial conjugates is the difference of the square of the first term and the square of the second term. So for example, a plus b, a minus b. This is an example of the difference of squares. So notice, when you multiply binomial conjugates together, you get the difference of 2 perfect squares. So binomial conjugates, a plus b, a minus b, when I actually multiply these together, I get the difference of 2 perfect squares. A is a perfect square and b is a perfect square. So when you multiply numbers and raise that product to a power, the following happens. This is a review from, I believe, 5.1 and 5.2. So xy to the n power is the same as x to the n times y to the n. This is known as the distributive property of exponents over multiplication. So I'm actually taking this n and distributing to the x, distributing to the y. The distributive property of exponents over multiplication, because inside the parentheses I am doing x times y. So let's perform the indicated operation. In this case, xy in parentheses to the 7th, I distribute x to the 7th, y to the 7th. In this case, inside the parentheses, so the base is 7x. Like in this case, the base was xy. So I distribute the exponent of 2 to the 7 and the exponent of 2 to the x. 7 squared, x squared, or just 49x squared. Same here. Distribute the exponent of 4 to the negative 2, the exponent of 4 to the x. I have negative 2 to the 4th, x to the 4th, which gives me 16 x to the 4th. Now, square the following. If you remember, the last topic we discussed was the distributive property of exponents over multiplication. This is not multiplication, so I cannot do x squared plus 5 squared. I cannot do 4a squared minus 7a squared. In this case, I must multiply x plus 5 times x plus 5, and in this case, 4a minus 7 times 4a minus 7. Well, if you recall, this is multiplying two binomials I must FOIL. So x times x, x squared, x times 5, 5x, 5 times x, 5x, 5 times 5, 25, and remember to combine like terms, and we have this quadratic. Similarly, with this problem, 4a minus 7 times 4a minus 7, we must FOIL, combine any like terms, and our answer is 16a squared minus 56a plus 49. Squaring these. So we're going to please pause the video and try to square these. Keep in mind what happens when you square a base that has an exponent in the base. Okay, first thing, we are multiplying this binomial times itself, and then we FOIL. So 2a squared times 2a squared will be 4a to the fourth. And then 2a squared times 4b will give me 8a squared b. And our result is this. Combine like terms. And this is our answer. Be careful when you have negative coefficients. Be very careful when you have negative coefficients. So negative 3x minus 4y times negative 3x minus 4y. A negative times a negative gives me a positive. So please be careful when you're multiplying and your coefficients are negative. And then combining like terms, we have this. So squaring binomials. In squaring binomials, the square of a binomial equals the first term squared plus or minus twice the product of the two terms plus the second term squared. I know that sounds like a lot. For example, a plus b squared. You can do one of two things. You can do a plus b times a plus b and FOIL, or there is a property or a shortcut where you take the first term and you square it, the second term and you square it. The middle term will always be 2 times the first term times the second term. So in this case, a squared, b squared, 2 times a times b, 2ab. In this case, I am squaring a binomial, a squared, b squared, 2 times a times negative b gives me negative 2ab. If you forget this property, you can always multiply this binomial times itself or this binomial times itself. So let's find the following. What if we substitute an expression a minus 3 in for x? So f of a minus 3 equals a minus 3 squared plus 5 times a minus 3. First thing I notice is I am squaring a binomial. I could either use the property I just learned, or I could multiply a minus 3 times a minus 3 by FOILing. So a minus 3 times a minus 3. If you use the property, we have a squared, then negative 3 squared, which is 9, and then in our middle term will be 2 times negative 3 times a, which gives us a squared minus 6a plus 9. And then since we have addition here, we can remove our parentheses by distributing 5 to the a and 5 to the negative 3. And then we can combine all our like terms. So f of a minus 3 equals a squared minus a minus 6. Now, to evaluate quadratic functions and rewrite them in standard form. This is what's called vertex form. We'll get that we'll get to that in another lesson. But this is in what's called vertex form. So we're going to write this in standard form where we have a quadratic in descending order. Remember, you cannot multiply negative 3 times anything in this parenthesis until we take care of exponents. Order of operations, you must do what's inside parentheses first, exponent second, multiplication third, or division, depending, and then addition, subtraction last. So in this case, I cannot distribute by multiplication negative 3 until I square x minus 4. So negative 3 times x minus 4 times x minus 4 plus 8. Now in this case, I can either distribute the negative 3 to x and the negative 3 to negative 4, or I could FOIL x minus 4 times x minus 4. Now distribute negative 3 to everything inside the parentheses. And lastly, combine like terms. Now remember, binomial conjugates are the sum and difference of two terms. So for example, x plus 5 and x minus 5 are binomial conjugates. 4a plus 7, 4a minus 7 are binomial conjugates. 15 plus xy, 15 minus xy are binomial conjugates. So let's take a look and see what happens when you multiply binomial conjugates. If you remember, if I took a plus b and squared it, a plus b times a minus b, I square the first and I square the second. This was our second vocabulary, difference of squares. So when I multiply binomial conjugates together, all I do is I square the first term, I square the second term, and I subtract those two. So let's look. So this should give us x plus 5 times x minus 5, x squared minus 5 squared. 4a plus 7, 4a minus 7, square the first. X squared minus 25, once that's simplified. So square the first, 4a squared minus 7 squared, 16a squared minus 7 squared. And lastly, 15 squared minus xy squared, 225 minus xy squared. Please remember to complete the My Math Lab homework for lesson 5.6. Thank you.